Chapter 16, Displaying Data. So displaying data in research is the last step of the research process. It is important to display data accurately because it helps in presenting the findings of the research effectively to the reader. Without it, the data looks too disorganized and the reader cannot make inferences and even cannot understand. So that's why displaying the data is very important. Objectives. In this chapter, you will learn about number one, methods of communicating and displaying analyzed data in both quantitative and qualitative research. Second is how to present your data in tables. Number three is different types of graphs and how to use them to represent your data. Four ways of communicating and displaying the analyzed data. We have number one, through text, number two, tables, number three, graphs, and number four, through statistical measures. So we will start on the first way on displaying the analyzed data through text or what we know as your essay presentation. So this is a few figures are embedded in the paragraph of the text of the paper. So this is the most common method of communication in both the quantitative and the qualitative research. So writing should be in thematic form. So it has the contents of the following. We have written around various themes of your report. Number two, findings should be integrated into the literature, citing references using an acceptable system of citation. Third is to follow a logical progression of thoughts. And fourth is the layout should be attractive and pleasing to the eye. Effective data presentation in your research papers requires more understanding for your reader and, of course, the use of the elements that comprisingly your tables. So, tables have several elements, including the legend, column titles, and the body. As in your manuscript writing, it is also just an important to structure tables so that the readers can easily understand them. So, what are the five parts of tables? So, parts of the tables are the following: we have the title, the stab, the column headings, the body of table, and the supplementary notes or footnotes. So, the first is we will discuss what is title all about. So, title is speaks about the contents of the table. So the title should have the concise and the precise and no extra details. The title should be written in sentence case. So this normally indicates the table number and describes the type of data the table contains. So each table has its own number. So for example, you have table 1.1, 1.2, and etc. So tables numbered sequencing in order are the ones that appear in text. And the main advantage of this procedure is that if becomes necessary to add or delete a table when revising your report or your research paper, then the table numbers for that chapter only rather than for the entire or the whole report you will delete or you will delete or you need to change. So this title indicates clearly and briefly and comprehensively what the figures in the body of the table stands for, and of course how the data are classified, where and when they were obtained. So usually it is placed above the body of the table. So let's proceed on step. So in when you talk about stab, it's more on the column is at the first column on the leftmost of the table, and this is what we know as your stab. So a stab has a stab heading at the top of the column. Not all tables have stab. The stab shows the subcategories that are listed along the y-axis or your left-hand column of the table. So this stub has list the items about which information is provided in the horizontal rows to the right and describes the stub as a vertical listing of categories or individuals about which information is given in the columns of the table. So stub indicates the basis of classification of rows and or horizontal series of figures. So what about these column headings? Column headings, or what we know as your caption. It is the variable might have subcategories which are captioned. So these subcategories are provided on the on the x-axis. So the captions are provided on the top of each column. So column headings indicate the basis of classification of the columns or vertical series of figures. It represents your x-axis, so meaning from the top of the table. So for example, in your univariate, so tables displaying information about one variable, so the column heading is usually the number of respondents and or the percentage of the respondents. Whereas in your bivariate tables, so these tables displaying information about two variables. So it is a subcategories of one of the variables displayed in the column headings. So that is what we know as your caption or column headings. What about your body of table? The body is the actual part of the table in which it resides, or it's in the whole values and even the results and analysis. So it made up of the figures filling the cells or compartments and the cell housing the analyzed data. So that is the entire body or the entire information there that you need to fill in. You need to fill in the cells and even compartments. The last part of the table is your supplementary notes, or what we know as footnotes. So there are four types of footnote. So number one, we have the source notes. Number two, other general notes. Number three is notes on specific parts of the table. And number four is the notes on the level of probability. So if data is taken from another source, then you have an obligation to acknowledge this. So the source should be identified at the bottom of the table and is labeled by the word source, and then you cite the name of the author, or other explanatory notes should be added at the bottom of the table. So these are the 5 parts of the table. So as you can see, this is the figure 16.1, or the structure of a table. So as we recall, you have here the first part of the table, you have the title, and then you have the stub, and then you have also for the column heading, and you have the body of the table and the footnote. So look at the footnote, so you will indicate the source. So specifically where did you get that information, then you can take it down there. So let's proceed on the types of tables. So there are 3 types of tables. So we have here the univariate. Univariate, also known as your frequency table. This is the information about one variable. The second type of table is the your bivariate, so also known as your cross tabulations, containing information about two variables. And last is the polyvariate, or what we know as the multivariate, containing information about more than two variables. So the first example here is the first type of table is what we know as the univariate. So in table 16.1, these are respondents by age. So you have the frequency table for one population. This is a hypothetical data. So in this table, you can see the details here from your respondent's age. So you have the age bracket, so less than 20 years. You have 20 to 24, 25 to 29, until the last part, which is 55 and above. And on the right side, the column here is your number of respondents, which is your frequency table for one population. So this is an example of the univariate, or what we know as you will having a display, or also known as your frequency table, containing information about one variable. So this is an example of your univariate. In table 16.2, you have your respondents by age and frequency table comparing of two populations or hypothetical data. So figures in parentheses are percentage, so rounding error. So again, you have here the respondents by age. So if you can see, you have the age bracket here from less than 20. You have 20 to 24, 25 to 29, 30 to 34, 35 to 39, and so on. And then you have here from the last is there is no response in the total. So on the right side, the next column is population A and as well as population B. This is another example of your univariate. So let's try to look at the second type of table, which is an example of your bivariate. So in table 16.3, these respondents by attitude towards uranium mining and age, meaning this is partly a cross tabulation, or we have here a hypothetical data. So as we all know that bivariate, or also known as your cross tabulations, containing information about two variables. So as you can see on the left side, this is your first column. If you have the attitude towards uranium mining, and you have your categories there in rows, and then on the right side you have the specific age, and between the uranium mining and the age, and you have the last part is the total. So here this is an example of bivariate, meaning you have two variables comparing into or containing about two variables. So what does this variable mean? You have the uranium mining and versus the age, and you have the two information or two variables. So let's try to look at the example of another type of table, which is your polyvariate or multivariate, meaning this information or containing information about more than two variables. As you can see in table 16.4, you have the attitudes towards uranium mining by age and gender. This is in hypothetical data. So as you can see on the first column, you have your attitude towards uranium mining, and then you have the number of respondents according to by age and gender. And you have here gender, you have male and female. So this is an example of your multivariate. Another type of your another example of your table as in multivariate or polyvariate. So let's proceed on the types of percentage. So for accurate and effective interpretation of data, you may need to calculate measures such as percentage, cumulative percentage, or ratios. So let's try to have an example regarding on the percentage in a univariate as one of the type of table. So in the univariate, as the total number of respondents in each sample or population group normally varies in percentage. Enable this or enable you to standardize them against a fixed number, or what we know as 100. This standardization against 100 enables you to compare the magnitude of the two populations within the different subcategories of a variable. So in a cross tabulation, the subcategories of both the variables are examined in relation to each other to make this table less congested. So there are the three types of percentage. So we have here, number one, you have the row percentage. Number two is the column percentage, and number three is the total percentage. So if we talk about row percentage, they calculated from the total of all the subcategories of one variable that are displayed along a row in different columns in relation to only one subcategory of the other variable. So if we look at the example of the univariate, as we can see here that no, let's try to let's try to check on the table at 16.3 on the respondents by attitude towards uranium mining and age, a cross tabulation. So an example of this, you have the row percentage, so they abbreviated it as an at sign, and then the column percentage will be on the asterisk. So in this bivariate presentation, so in the under the attitude towards uranium mining, in the row the row percentage, so if you can see here that there is a specific age bracket and there is a specific percentage. So you look at the at sign, meaning you can determine that this is in a row percentage. So when you interpret this one, so for example, you have the strongly favorable on from the left side to the right side, the total here is 16. So for at the age of 25 to 34 years old, so the total percentile here is 12.5. So there are two out of 16. Now ages 25 to 34 has this strongly favorable towards or attitude towards the uranium mining. This is how you are going to interpret in the use of this row percentage, so that you will know there are, for example, in 45 to 54. So in this part you have 43.6, meaning under the age of 45 to 54 has a strongly favorable attitude towards the uranium mining. Now, under the age of 25 to 34, strongly, from the row percentage we're in, you can see that there are 24 under 25 to 34, 24 who are strongly unfavorable at the attitude towards the uranium mining. So this is how you're going to read on based on the types of percentage. So what about this column percentage? In the column percentage, you can hold age at a constant level and examine variations in attitude. So as we go back again on the multivariate, so you have here based on the column at what age now corresponding age, and then you check on the column percentage how much is the percentile. So for example, on this one there are 24 age 25 to 34 who are strongly unfavorable towards attitude towards the uranium mining. So a total of 56 all in all who said that strongly unfavorable based on the attitude towards the uranium mining. So, and you can see also that a certain percentile, under the 25 to 34 age, there are 42.9 who are strongly unfavorable. So you base on the column. Column is here on the upper part. Now look at the age. This is partly on the column, and then there's an asterisk. So you base that one on the table of bivariate so that you will understand what is column percentage all about. And then the last one is the total percentage. In the total percentage, this is the standardized, or this standardize the magnitude of each cell. That is, it gives the percentage of respondents who are classified in the subcategories of one variable in relation to the subcategories of the other variable. So again, let's go back on the table on the bivariate as an example. So I total here, you can see at the bottom part there is a corresponding total. So you have 36 under the age of 25 to 34. So, and you will have also the corresponding total for this table, that you'll be able to identify the specific criteria under the attitude towards uranium mining. So that is partly the steps of percentage. So let's proceed on the third types, or the third ways of communicating and displaying in analyzing and displaying the data. So displaying the analyzed data. So the third step is by the use of your graph. So in the graph, it can be constructed for every type of data. It could be quantitative and qualitative. And for any type of variable, or the levels of your data, or level of measurement, or measurement scales. So it's measured on a nominal, ordinal, interval, or ratio. So as we all know that graph is based entirely in the table data, and therefore can tell that no story that cannot be learned by inspecting a table. So in the graph, this allows the researcher to have an overall view of the statistical data. The detailed information is not shown, but the trend or the relative frequencies can readily be appreciated or recognized in the form of graph or even diagrams. So the relative values can be seen and estimated from the vertical scale, or sometimes the horizontal scale. So again, with reference of your type of variables and measured on a nominal, ordinal, interval, or ratio, so that you'll be able to present this one in a graph form or in a diagram. So there are different types of graph, and your decision to use a particular type should be made on the basis of the measurement scale. Is it nominal, ordinal, interval, or ratio scale? This is what the measurement of a variable you'll be using. And it is also equally important to keep in mind the measurement scale when it comes to the interpretation. So as we all know that the type of graph you choose depends upon the type of data you are displaying. So for categorical variables, then you can construct only bar charts, histograms, or pie chart. Whereas for continuous variables, in addition to the above, you have also the line or the trend graph can also be constructed. So the number of variables shown in a graph are also important in determining the type of graph you can construct. So when constructing a graph of any type, it is important to be acquainted with the following points. Number one, you have here a graphic presentation is constructed in relation to two axes. You have the horizontal and the vertical. The horizontal axis is called the abscissa, or commonly known as the x-axis, and the vertical axis is called the ordinate, or commonly known as the y-axis. This is from minimum in 1978. Another one, if a graph is designed to display only one variable, it is customary, but not essential, to represent the subcategories of the variable along the x-axis and the frequency or count of that subcategory along the y-axis. So the point where the axes intersect is considered as the 0 point for the y-axis. When a graph represents two variables, one is displayed on each axis and the point where they intersect is considered as the starting or the 0 point. That's how you take note on the x-axis versus the y-axis. So number 3 is a graph, like a table, should have a title that describes its contents. So the axis should be labeled also. Number 4 is a graph should be drawn to an appropriate scale. It is important to choose a scale that enables your graph to be neither too small nor too large, or your choice of scale for each axis should result in the spread of axes being roughly proportionate to one another. Sometimes, to fit the spread of the scale, when it is too spread out or on one axis or one or both axes, it is necessary to break the scale and alert readers by introducing a break, usually two slanting parallel lines in the axis. So the first type here is all about histogram. So histogram is, as we can see, it consists of rectangles that are drawn next to each other on the graph. So the rectangles have no space in between them. So can be drawn for a single variable as well as for two or more than two variables. So the height of the bars in the histogram represents the frequency of each variable. It can be drawn for both categorical or continuous variables. So when interpreting a histogram, you need to take into account whether it is representing categorical or continuous variables. So we have here an example, figure 16.2a. You have the two-dimensional histogram, so there's no space in between. And you have also figure 12.6b. You have the three-dimensional histogram. And the figure 16.2c, you have the two-dimensional histogram with two variables. So if you differentiate between the three figures, so that you'll be able to identify. So in each histogram, there's no space in every rectangle. So in the figure 16.2c, if you can see, these are two variables. So you have the dark one, the male and the female. So you can identify here. And here on the figure 16.2b, this is the example of the three-dimensional histogram. You have the age of respondents, and there's the corresponding figures here. And then on the first figure, which is 16.2a, this is an example of the two-dimensional histogram. The second type of graph is what we know as your bar chart, or a bar chart, or other known as your diagram. Diagram is used for displaying categorical data. So a bar chart is identical to a histogram, except that in a bar chart, the rectangles representing the various frequencies are spaced, thus indicating that the data is categorical. So the bar chart is used for variables measured on nominal or ordinal scales. So the discrete categories are usually displayed along the x-axis and the number of percentage of respondents on the y-axis. However, as illustrated, it is possible to display the discrete categories along the y-axis. The bar chart is an effective way of visually displaying the magnitude of each category of a variable. So as we can see on figure 16.3 bar chart, so there are different representations of presenting or displaying your bar chart. It could be upper up, I mean in a position wherein just like your histogram, but there is a space in between. That's the difference between bar chart and the histogram. So another type is what we know as the stack bar chart. So this stack bar chart is similar also to a bar chart, except that in the former, each bar shows information about two or more variables stacked onto each vertically. So the sections of a bar show the proportion of the variables they represent in relation to one another. So a stack bar can be drawn only for categorical data. So figure 16.4, this is an example of your bar chart. So you have the legend there, you have the females and males, and the attitudes representing the attitudes towards uranium mining by gender. So you have strongly favorable, uncertain, favorable, and strongly favorable. And then on the left side, this is the number of your respondents. I think this is the age bracket. So, and by gender, so you will identify who are those male and female. So on, if you can see on the legend, so you have the lighter part is the female and the dark shade is the male. So that is an example of a stack bar chart. So another type is the 100% bar chart. So this 100% bar chart is very similar to the stack bar chart. In this case, the subcategories of a variable are converted into percentage of the total population. So each bar, which totals 100, is sliced into portions, so relative to the percentage of each subcategory of the variable. So if you can see on 16.5, the 100% bar chart, so still you have the legend below. You have how many are females and male on when they answer on the attitudes towards uranium mining by gender. This is a hypothetical data, and you have the same legend. You have the females and the males. So the lighter part, the lighter shading is the females, and whereas the darker shade is the males. And on the left side, you have also the percentage of your respondents. So the highest here from the top is from 0 to 100. So this is what we know as your 100% bar chart. So let's proceed on frequency polygon. So this frequency polygon is also very much the same with the histogram. It consists of frequency rectangles drawn next to each other, but the values taken to draw the rectangles is the midpoint of the values. So the height of the rectangles describe the frequency of each interval. So a line is drawn that touches the midpoints at the highest frequency level on y-axis, and it touches the x-axis on each extreme end. But one problem is in constructing a frequency polygon is what to do with the two categories at other at other extreme. This is also to bring the polygon line back to the x-axis. Imagine that two extreme categories has an interval similar to the rest and assume the frequency in these categories to be 0. So from that midpoint of these intervals, you extend the polygon line to meet the x-axis at both ends. A frequency polygon can be drawn using either absolute or proportionate frequencies. So this is an example in figure 16.6, the frequency polygon. So have you the age of the respondents and as well as the number of respondents on the left side. So this is your type of histogram. Just like similar to histogram, there's no space in between in the rectangles. Another type is what we know as the cumulative frequency polygon, or what we know as your cumulative frequency curve. This is drawn in the basis of cumulative frequencies. The main difference between a frequency polygon and a cumulative frequency polygon is that the former is drawn by joining the midpoint of the interval, whereas in the latter is drawn by joining the endpoints of the intervals, because the cumulative frequencies interpret data in relation to the upper limit of an interval. As a cumulative frequency distribution tells you the number of observations less than a given value and is usually based upon group data. To interpret a frequency distribution, the upper limit needs to be taken. It is drawn using a cumulative frequencies or what we know as your y-axis, and the values on the x-axis are taken by using the endpoint of the interval. The endpoints of the interval are joined to each other, the reason being that the cumulative frequency is always based on the upper limit of an interval. As you can see on figure 16.7, the cumulative frequency polygon, you have the age of respondents. So you have here from the last part, which is 60 to 64, and almost reach into 100 now as the response of the number of respondents under this scenario on the attitudes of uranium towards the uranium mining. So you have here the age of respondents versus the number of respondents. Another type is what we know as the stem and leaf display. In this stem and leaf display, if rotated to 90 degrees, it will become a histogram. So it is effective and quick and simple way of displaying a frequency distribution. This diagram for a frequency distribution running into two digits is plotted by displaying digits 0 to 9 on the left of the y-axis, representing the tenths of a frequency. So the figures representing the units of a frequency. So wherein the right-hand figure of a two-digit frequency are displayed on the right of the y-axis. Take note that the stem and left display does not use group data but absolute frequencies. With this technique, some of the descriptive statistics relating to the frequency distribution, such as the mean, the mode, and the median, can also be easily ascertained. Is also a possible for frequencies running into 3 and 4 digits until hundreds and thousands. So in figure 16.8, the stem and leaf display is like this. So you have here the specific numbering and there is also certain numbers on the right side. Another type is your the pie chart. So the pie chart is very different way to display data. So in the pie chart is a form of or is just like a circle. As a circle, it has 360 degrees, so it is taken in percentage, and the whole pie or circle represent the whole population. So the pie or circle is divided into slices, or what we know as sections. So each section represents the magnitude of the category or the subcategory. So the pie chart is another way of representing data graphically, and this time is a form of circle. So there are 30 there is or there are 360 degrees in the circle, and so for the full circle can be used to represent 100% or the total population. So the circle or pie is divided into sections in accordance with the magnitude of each subcategory, and so each slice is in proportion to the size of each category of a frequency distribution. So the proportions may be shown either as an absolute numbers or as a percentage. So manually, pie charts are more difficult to draw than other types of graph because of the difficulty in measuring the degrees of the pie or circle. They can be drawn for both qualitative data and variables measured on a continuous scale but grouped into categories. So this is an example of your pie chart in figure 16.9. So you have 2 and 3 dimensional pie charts. So you have here the respondents by age, and according to the attitudes towards uranium mining, this is the hypothetical data. So you have the 2 and 3 dimensions. Another type is what we know as the line diagram or the trend curve. So this is a set of data measured on a continuous interval or a ratio scale, can be displayed using a line diagram or curve or trend curve. A trend line can be drawn for data pertaining to both a specific time, for example 1995, 1996, 1997, or a period of example 1985 to 1989, 1990 to 1994, and 1995, and so on. So if it relates to a period, so the midpoint of each interval at a height commensurate with each frequency, as in the case of a frequency polygon is marked as a dot. So these dots are then connected with straight lines to examine trends in a phenomenon. So if the data pertains to exact time, a point is plotted at a height commensurate with the frequency. So these points are then connected with straight line. So the trend curve is also known as your line diagram. So it is drawn by plotting the midpoints on the x-axis and the frequencies commensurate with each interval on the y-axis. So a trend curve is drawn only for a set of data that has been measured on the continuous interval or ratio scale. A trend diagram or the line diagram is most suitable for plotting values that shows change over a period of time. So this is your line diagram or trend curve. Another one is a line diagram is a useful way of visually conveying the changes when long-term trends in a phenomenon or situation need to be studied, or the changes in the subcategory of a variable are measured on an interval or a ratio scale. So trends plotted as a line diagram are more clearly visible than a table. For example, a line diagram would be useful for illustrating trends in birth or death rates and changes in population size. So this is your line diagram. Figure 16.10, this is the line diagram or the trend curve. So you have also the legend there, group 1, group 2, group 3, and group 4. So the duration in months, and you have also the percentage of the current users. So you have a corresponding line graph, and also there's a legend for you to be able to determine if this is group 1, group 2, group 3, or group 4. Another type is what we know as the area chart. For variables measured on an interval or a ratio scale, information about the subcategories of a variable can also be presented in the form of an area chart. This is plotted in the same way as a line diagram, but with the area under each line shaded to highlight the total magnitude of the subcategory in relation to other subcategories. So in area chart is a variation of the trend curve. In area chart, the subcategories of a variable can be displayed. The categories in the chart are displayed by shading them with different colors or patterns. For example, if there are both males and females category in the data sheet, so both can be highlighted on this chart. So this is your area chart. So as you can see, the area chart in figure 16.11, so you have the legend for male and female, and then you can highlight this one either in colors or in a pattern, or you can highlight or shade into a color. You can do that. So as you can see, there is an age here on the bottom, and then on the left side there is a corresponding number of respondents. So this is to check on same on the attitude towards uranium mining in a hypothetical data. So as you can see on the female, the color is light gray, and then on the dark shade is more on males. So this is an example of an area chart. So let's talk about scattergram. So when you want to show visually how one variable changes in relation to a change in the other variable, scattergram is extremely effective. For scattergram, both the variables must be measured either on interval or ratio scales, and the data on both the variables need to be available in absolute values for each observation. So you cannot develop a scattergram for categorical variables. Data for both variables is taken in pairs and displayed as dots in relation to their values on both axes. So a very simple way to plot the data on a chart is used for data where the change or in one variable affects the change in the other variable. So the frequency against each interval is plotted with the help of dots. That is what we know as your scattergram. So let's try to check on the scattergram. So in figure 16.12, this is an example of your scattergram. Let us take the data on age and income for 10 respondents of a hypothetical study in table 16.5. So the first table shows wherein the age and income data are presented. So we have the respondent on the left side, and then the first column is your income, and then the other one is the age. So after that one, it transcribed into a form of a scattergram. So in the scattergram, you have the dots there, and then at the bottom you have the age, and corresponding on the right or left side is on your specifically for your income. So the relationship between age and income based upon hypothetical data is shown in figure 16.12, your scattergram. So let's talk about the last part, which is your statistical measures as one way of communicating and displaying the analyzed data. So these statistical measures, wherein use of statistical measures is dependent upon the type of data collected, your knowledge of statistics, and the purpose of communicating the findings, and the knowledge base in statistics of your readership. So there are many statistical measures ranging from very simple to extremely complicated, Then on one end of the spectrum, you have simple descriptive measures such as your mean, mode, median. And on the other, there are inferential statistics measures like analysis of variance for your ANOVA. You have the factorial analysis, the multiple regressions. So before using statistical measures, make sure that the data lends itself to the application of statistical measures. Then you have sufficient knowledge about them and your readership can understand them. So let's take a look at our reference. This is from Ranjit Kumar, Research Methodology, a step-by-step guide for beginners, 3rd edition, 2011. All right, thank you so much for your time, and thank you for listening and for your time for today. So let's see you around on our next module. So thank you so much for your time and have a great day. Goodbye.